Let's look at an example of verifying an identity that involves the sum and difference identities. In this example, we have the sine of x of the quantity x plus y times the cosine of y minus the cosine of the quantity x plus y times the sine of y, and we want to show that that is actually equal to just sine of x. So to go through this, there are several ways that we could do this. Maybe kind of the more obvious option is when we see that sine of x plus y and the cosine of x plus y, those look like sum identities. Okay, so we know that the sine of x plus y has to equal the sine of x, the cosine of y, plus the cosine x, and this times the sine of y. And we know that cosine of x plus y is going to equal the cosine of x, the cosine of y, minus the sine of x, sine of y. So those are the identities that we can use here. Okay, so if we go through and do this, this is going to be kind of a long process, but I'm going to replace the sine of x plus y with this identity. And all of that is going to then be multiplied by the cosine of y. So I'm going to replace sine of x plus y as the sine of x cosine y plus the cosine x sine y. All of that is multiplied by the cosine of y. Minus, I'm going to replace the cosine of x plus y with its whole identity. And again, all of that's multiplied by the sine of y. So that's going to look like the cosine x cosine y minus a sine x sine y. And all of that is again multiplied by a sine y. So the algebra that we could do here is we could go ahead and distribute the cosine y into the first parentheses and the sine y into the second parentheses. And again, this is kind of a long expression, but that's okay. So we're going to have sine x cosine y times a cosine y. That's going to give us sine x times a cosine squared y. We then have cosine x sine y times a cosine y. None of those are the same term, so we're going to just have them all there. Cosine x sine y cosine y. Do the same thing on the second part of the fraction. So we're going to take minus, we're going to have cosine x cosine y times a sine y. So that's just going to be minus cosine x cosine y times sine y. And then the last piece, just looking at our parentheses first here, is minus a negative. So this is actually going to become a plus. And then we're taking a sine x times a sine y times another sine y. So this is going to be sine x times a sine squared y. Okay. If you look at the middle terms, both of them have the same parts. They both have a cosine x, they both have a cosine y, and they both have a sine y. One is positive, the other is a subtraction. So these are actually going to just cancel out. So we're left with the sine of x times the cosine squared y plus the sine x times the sine squared of y. Both of these terms have a sine x in them, so we can factor that out. So we're going to have sine x times a cosine squared y plus a sine squared y, which cosine squared plus sine squared is just a 1. That's our Pythagorean identity. And so this is just going to turn out to be sine x times a 1, which is just a sine of x. And if you look, that's what we needed to show that it was equal to. Okay, so again, that's one way that we could verify that the sine of x plus y times cosine of y minus the cosine of x plus y times the sine of y is equal to sine of x. There's a shorter way, a quicker way to do this. Okay, and that's looking at the inside parts. We have a sine, a cosine, and a sine, right? If you look at the insides, we have an x plus y and a y. So think of that as like a and b. And then we have x plus y and y. Well, that's the same thing. That's an a and a b. So really, I could take that whole left side and rewrite it as the sine of a cosine of b minus the cosine a and the sine of b. And I know that that has to equal, so sine cosine minus cosine sine, that is the sine of a minus b. So again, I could use this identity, which is a little different than the ones we used before, but it's the same family, right? Still sum of difference identity. I could replace the whole left side of this equation as the sine of a minus b. And then remember, as I pointed out here, a is x plus y, and b is the y. So I'm really just looking at the sine of x plus y minus y. I mean, obviously, the y's are going to cancel here, and so this just also turns out to be the sine of x. Again, that matches what we need it to match. Okay, so in this example, I wanted to work it both ways so you can kind of see a lot of these problems have different ways to do it. Sometimes one way is going to take you down a longer path, longer expressions, multiple steps, and others may give you really short, very few steps, very quick work. It's just a matter of what you can see and what you can do. Okay.